Hello and welcome to today's video where we move on in the story of stoichiometry. You've seen the introductions, exactly how to decipher or decide what kind of question in stoichiometry have you been given. Is it mass to mass, mass to volume, or the others as the case may be. If you haven't gone through it, look through the intro video on the topic of stoichiometry. However, we are going to be sharing it. So practically in these videos, we are going to be talking about or discussing mass to mass relationships. Then when we are done, we'll move on to mass to volume and other cases as we move on in time. So every question I'm going to see here is practically based on mass. As you can see for the very first question, how many grams of a metal we combine, or of the metal, we combine with 10 grams of oxygen? Grams and grams. That means we are dealing with mass to mass relationship. So let's go ahead and solve the question. In this case, as I already said, the most important thing as always is the balanced chemical equation. And if you check here, there is no chemical equation. So you have to, by your own self, bring out the chemical equation from the question. Decide the reactants, decide the products, and much more importantly, write down or use their proper chemical formulas. So from the question, we are told that a metal forms an oxide. When a metal forms an oxide, it means that that metal is reacting with only oxygen. It doesn't apply to only metals. Whenever something is called an oxide, it means that thing is reacting only with oxygen or is combined with only oxygen. So the metal we are given as X combines with oxygen. Now you always remember that oxygen is always diatomic. So your subscript of 2 has to be here. And then we are already given the formula for the metal. That's X2O3. So this is our skeletal equation. We have brought out the reactants and we have gotten the products. However, we need to balance the chemical reaction. Again, go through my videos on balancing chemical reactions and you see exactly how to go about that. But in this case, simply place a 2 here, place 3 here, and then place a 4 here. So you can see for the metal we have 4 atoms, oxygen 6 atoms, and oxygen here 6 atoms, and the metal 4 atoms. Alright, so now it is time to read the question and decide what are we dealing with. What do we need to solve? We are asked how many grams of the metal, so we are dealing with the metal, and we are asked, or we are given the mass of oxygen, so we are dealing with oxygen. So practically in this equation, we only need the metal for X, the metal X, remember, and we need oxygen. That's what we need to solve as we move on. Alright, so the next thing is, the simple way I like to do it is, first thing first, get the number of moles, which is N, get the molar mass, and then simply get the mass, or as some may call it, the reacting mass. So what is the number of moles? Again, check the introductory video, you get that. The number of moles is simply the stoichiometric coefficient, which is 4 in this case, and in this case we have 3 as the number of moles. Next thing is to get the molar mass. In getting the molar mass, you only need the molar mass of the substance involved, not the number of moles in this case. For X, the molar mass we are given as 56. Now it is because X is monoatomic, it is only one atom. So when it's monoatomic, it is simply 1 times the relative atomic mass. So 1 times 56 still gives us 56. However, in the case of oxygen, you can see that the relative atomic mass of oxygen is 16. However, oxygen is always diatomic, that's why you have O2. So therefore, the molar mass of oxygen will be the relative atomic mass times 2. That is 2 times 16, and that gives us 32. Now, what is the mass or the reacting mass? Remember, mass is number of moles times the molar mass. So it is pretty easy. Just multiply these two figures and multiply these two figures. So 4 times 56, that should give us 224, I think. Yes, that gives us 224. 3 times 32, that gives us 96. So that's the very first thing you do. You just extract the information from your chemical reaction. And from our chemical reaction, we have seen that 224 grams of the metal reacted with 96 grams of oxygen. And that's what we simply come to. Again, let's have the metal and oxygen. So we have gotten it now that 224 grams of the metal reacted with 96 grams of oxygen. What does the question say? How many grams of the metal? How many? We don't know. So we simply say X grams of the metal will react with 10 grams of oxygen. Once you are done, you simply, guess you can say cross multiply. That means 96x will be equal to 224 times 10. So therefore, x divided by 96 will be 224 times 10 divided by 96. And so therefore, when you divide that, that will give us 23.3 grams. So it therefore means that 20.3 grams of the metal will combine with 10 grams of oxygen. So you can see the steps are quite simple. Decide, according to the question, what do you need to solve with? Just the metal and oxygen. Then from the chemical equation, your balanced chemical equation, extract the information that you need. What reacted or what combined. You get your answer. And then you combine that with the question, the information given in the question, and you simply get your answer. Now, same thing here. You can see 12 grams of carbonates was given, and then we are asked to calculate the mass of zinc chloride. So that simply means that, again, it is a mass to mass relationship. So this is how you decide these things. The atomic masses were not given. I guess you need to learn them at times. I always advise people to learn these atomic masses because there are some questions you get, it is not given, but some are quite popular. Like oxygen, people know is 16, carbon, people know is 12, hydrogen, people know is 1, chlorine, people know is 35.5. However, depending on the curriculum, the values can be different. So according to your curriculum, learn some of these atomic masses. But for the case of this question, I will just provide the information. Like I said, carbon is 12, oxygen is 16, chlorine is 35.5, hydrogen is 1, and then zinc is 65. That is their atomic masses. So note them. If you know them better, so if you're in an exam and you're giving the values, you're okay, you're good to go. But if you're not giving the values, then you already know what to solve with. Now, however, we have to be very careful with this question and read it. The first thing about any chemistry question is being able to read the question and interpret your question. If you see what is happening, zinc carbonate was heated strongly to a constant mass. It was the residue that was treated with hydrochloric acid. In other words, zinc carbonate was not what reacted with hydrochloric acid. It was the residue after heating zinc carbonate. So therefore, that is practically a decomposition reaction. So we have to ask ourselves, when zinc carbonate is heated, what happens? Let me just put heat here. Now you know most times, when carbonates are heated, you tend to liberate the oxide. If it's a metallic carbonate, mostly, you tend to liberate the oxide of the metal and carbon dioxide. That simply means that you're going to have zinc oxide and carbon dioxide. Carbon dioxide is a gas. Zinc oxide is solid. If you check through, I think the reaction is already balanced. So practically, the one that is solid is our residue. You can see the key to this question. It looks so simple. Somebody can be in a hurry and just go and say zinc carbonate reacted with hydrochloric acid. And then whenever acid reacts with carbonate, you have salt, which will also be zinc chloride. You have a salt, you have carbon dioxide, and you have water. And you go ahead and start solving. But that will most likely give you a wrong answer. So you have to read the question carefully. It was heated. Okay, when it was heated, it gave something, the oxide and a gas, which is classified as the residue. So it is that residue that actually reacted with hydrochloric acid. Again, if you remember, oxide of zinc, they are amphoteric. So practically what that means is that when they react with acids, you are going to get salt and water. So you are going to have zinc chloride and water. Now we have to check if our reaction is balanced. It is not. Again, check my videos on balancing chemical reactions and you have exactly how to balance chemical reactions. But if you check it out by counting one atom of zinc, 1 atom of zinc, 2 atoms of hydrogen, 2 atoms of hydrogen, 2 atoms of chlorine, 2 atoms of chlorine, 1 atom of oxygen, 1 atom of oxygen. So you can see that this question is now in 2 steps, not just 1 step. In other words, zinc carbonate did not directly react with hydrochloric acid to give zinc chloride. It was zinc oxide that did that. So if you want to know the amount of zinc chloride produced, you first of all need to determine the amount of zinc oxide that was produced, because it is that amount that will go ahead to react with hydrochloric acid to give you zinc chloride. So we now first of all have to determine from 12 grams of zinc carbonate, how much zinc oxide did it produce. So in the first case, let us get the value of the residue. So we are dealing with zinc carbonate and we are dealing with zinc oxide for the very first part of the equation. So we solve. We know we are dealing with zinc carbonates and we are dealing with zinc oxide. So let's get our values. Again, first thing first, get the number of moles. We get the molar mass. Since it's just mass to mass relationship, it is easier that way. And then we get the reacting mass. The number of moles, since there's no number in front, that means 1. For zinc oxide, that is 1. The molar mass means add all the atomic masses together. So in this case, we basically calculate it. Zinc, there's only 1 atom of zinc, which is 65. That means 65 plus 1 atom of carbon, which is 12. But there are 3 atoms of oxygen. Oxygen is 16. 16 times 3 gives us 48. So when we add 40 plus 12 is 60, plus 65 is 125. For zinc oxide, only 1 atom of zinc, which is 65, and 1 atom of oxygen, which is 16. When you add together, you have 81. So their masses, just multiply the number of moles times the molar mass. 1 times 125 is 125. 1 times 81 is 81. So what do? We simply go ahead now and say, from what we have, 125 grams of zinc carbonate produced 81 grams of zinc oxide. But we are given 12.5 grams. That was what was heated. So 12.5 grams will produce, we don't know the amount, x grams. So what do? Again, simply cross multiply. So you have 125x equals 81 times 12.5. X will therefore equal 81 times 12.5 divided by 125. And when you do this, you have 8.1 grams. So that means that when 12.5 grams of zinc carbonate was heated, it actually produced 8.1 grams of zinc oxide. And it was this 8.1 grams of zinc oxide that reacted with hydrochloric acid. So if any amount of zinc chloride was produced, it had to have come from this 8.1 grams of zinc oxide. So when we come to the next part, it was the residue that produced zinc chloride. So we are dealing with the residue, which is zinc oxide and zinc chloride. Again, it is the mass of zinc oxide that we have, and we need the mass of zinc chloride in this case. So we are dealing with zinc oxide and zinc chloride. Again, first thing first, get the number of moles, get the molar mass, and then you can guess the mass. The number of moles, the number in front, there's no number, it is 1. In this case, also 1. For zinc oxide, we have gotten the molar mass before, it is 81. For zinc chloride, zinc again is 65. There are 2 atoms of chlorine, that means 35.5 times 65. That gives us 71. That means we'll be having 136. To get the mass, therefore, the number of moles times the molar mass, 1 times 81 is 81, and then 1 times 136 is 136. So what we simply do is then, from our chemical equation that we have interpreted, 81 grams of zinc oxide produced 136 grams of zinc chloride. However, what we need now is we have 8.1 grams of zinc oxide. How much of zinc chloride will it produce? Again, once you're done with that, simply cross multiply. We now have 81x equals 136 times 8.1. So our final answer becomes, divide both sides by 81, 136 times 8.1 divided by 81. And when you do this, you get 13.6 grams. So that is simply our value. So when you check it out, you find out that 12.5 grams of zinc carbonate produced a residue, which was 8.1 grams. That residue produced 13.6 grams of zinc chloride. And that is practically how you solve this kind of question. Again, there's a possibility that if somebody makes the error and just use the value of zinc carbonate to calculate for the value of zinc chloride, the person may get the same answer. But the fact that the person got the same answer doesn't mean what the person did was right. So this is the actual process. Read your question, interpret carefully, and know exactly how you go about it. Alright, for the third and final question in this video, we are looking at mass of impurity. Now in chemistry, whenever you are told impurity, it doesn't mean it's dirty. It just means there is something else besides the main compound. So if you are told an impurity of calcium carbonate, it means that another substance is combined with calcium carbonate. So therefore, if you want to know how pure it is, you simply get the mass of calcium carbonate. That tells you how pure it is. Or, depending on how the question comes, you guess the mass of what was added, and then whatever is left has to be the mass of calcium carbonate. So that is basically the idea behind impurity. So that therefore means that if we read our question properly, what mass of impurity in a sample of calcium carbonate, or what is the mass of impurity rather, if 0.040 moles of carbon dioxide was formed when 5 grams of the sample reacted with excess dilute acid. So that simply is telling us that this thing that is reacting here, calcium carbonate, the whole sample that was placed in was 5 grams, but not all of them was calcium carbonate. So we want to know how much was calcium carbonate and how much was not calcium carbonate. The amount that was not calcium carbonate is what we refer to as the impurity. So how do we go about this? Well, it is to simply know that you can see that the carbonate reacted with hydrochloric acid and gave salt, carbon dioxide, and water. If it's an impurity, it will not have the same properties as calcium carbonate. So in other words, this reaction is a reaction characteristic of carbonates. So therefore, that impurity will not take part in this chemical reaction. So all we simply need to do is to determine what is the actual mass of calcium carbonate. Once we take that out, whatever is left is that thing that did not have the character of calcium carbonate, so it was not part of the chemical reaction. And that will be our answer. And that's the reason why it is very simple to say that the mass of impurity is actually equal to the mass of the whole sample, because the sample contains both calcium carbonate and the impurity, minus the mass of calcium carbonate, which we are going to be getting from this question. So now all we simply do is let us calculate the mass of calcium carbonate and take it out from the mass of the whole sample, which is 5 grams. So we want to determine the mass of calcium carbonate, and we are given information about the number of moles of carbon dioxide. That simply means that we are dealing with calcium carbonate and carbon dioxide. That's straightforward. Now, we are given value in moles. That means we can either solve the question as mole ratio, or we can solve it straight away as mass. So therefore, what I like to do in this case, if our answer was required in number of moles, we would have converted and solved as number of moles. But because our answer was required in mass, we can simply solve it as mass. So we are going to solve it both ways. So you have the power of choice to say, okay, I want to solve with mole ratio, or I want to solve it as mass. With mole ratio simply means that because your question was given in number of moles, solve it as number of moles, but at the end, because they ask for mass, you convert that value back to mass. So if it was mole ratio, it is quite straightforward. The number of moles for calcium carbonate is 1. Number of moles of carbon dioxide is 1. So you can see mole ratio, you don't need to solve the molar mass as you have been doing ever since. Then, we don't know the number of moles of calcium carbonate, that is X, but we know that 0.040 moles of carbon dioxide will be produced. That will be 0.40. So once you cross multiply, X times 1 is X, is equal to 0.040 moles. But as we said, the question is asking you for mass. So even if you solve with mole ratio like this, you must convert this value back to mass. So therefore, the mass of calcium carbonate, as you already know, mass is number of moles times the molar mass. The number of moles is 0.40 times the molar mass. Again, add all the atomic masses together. Calcium is 40. You can see again in this question it was not given, so it is good you recognize some of them. Carbon is 12. Oxygen is 16, but there are 3 atoms of oxygen. 16 times 3 gives you 48. When you add it all together, you get 100. And when you multiply this, you get 4 grams of calcium carbonate. So you can see, the whole sample was 5 grams, but out of that 5 grams, only 4 grams was calcium carbonate. So I believe you can easily get the impurity. That will be the mass of the sample, which is 5 grams, minus the mass of calcium carbonate. So you can see what the idea behind impurity actually is. The impurity will not behave as the actual compound. Now that is if you want to try to solve as mole ratio, because in the question you were given number of moles. What if somebody else decides and say, no, I like solving with mass? Well, nothing should stop you. Again, in that case, that means we're going to be getting the number of moles, we get the molar mass, and then we have to get the actual reacting mass. The number of moles, no number in front, means 1. 1. The molar mass, we already calculated here, we got 100. The molar mass of carbon dioxide, carbon is 12, Oxygen is 16. 16 times 2 is 32. 32 plus the 12 from carbon, we get 44. So the reacting mass, the number of moles times the molar mass, we get 100, 1 times 100. And here we get 1 times 44, which is 44. So from our chemical reaction, we now have that 100 grams of calcium carbonate produced 44 grams of carbon 4 oxide. But remember, you decided to solve with mass, not mole ratio. And the value of carbon 4 oxide you are given is actually mole in number of moles. So you have to convert a number of moles to mass. You simply remember that mass equals the number of moles times the molar mass. That number of moles you are given is for carbon 4 oxide. So therefore, the mass will be equal to 0.040 times the molar mass of carbon 4 oxide. We have gotten it as 44. So you can see you cannot come here and place 0.040 because that means you'll be comparing mass to number of moles, which will make your calculations quite wrong. You compare mass to mass, you compare number of moles to number of moles. So you convert either way you want it. So therefore, M will be, that's the mass of carbon 4 oxide in this case, is going to be 0.40 times 44, which gives us 1.76 grams. That therefore means that this particular thing is actually equivalent to 1.76 grams of CO2. So if you want to solve now, since you are dealing with mass, we are not using 0.040, we'll be using 1.76. So therefore, how many grams of calcium carbonate will produce 1.76 grams of carbon 4 oxide? Automatically, as usual, simply cross multiply. That therefore means that 44x equals 100 times 1.76. X becomes 100 times 1.76 divided by 44. And when you solve this, you simply get 4 grams. So you can see you get exactly the same 4 grams. But again, remember, as we have always said, always read your question properly. You are not asked for the mass of calcium carbonate, but you needed it to get the mass of the impurity. To now finally get the mass of impurity, we have already written the formula earlier. So therefore, our mass of impurity is the mass of the sample, which we are given as 5.0 grams, minus 4 grams. That gives us 1.0 grams. And that becomes our answer. So you can see, it is just that straightforward. We will still have more videos on mass to mass relationships. And then we'll move on to mass to volume and move on to other concepts of stoichiometry. Just one example, you can see carbon 4 oxide in this case is a gas, but we are given the mass, so we calculated it as mass. But it can be possible in another question, it is referred to in the situation of volume. Remember from the intro video, we will not be using 44 anymore because we are not looking for mass, we need its volume. We'll be using 22.4 dm cube. So watch out for those videos and always remember, like, share, and subscribe.